Leveraging your patents with the prototype, or vice versa. Hello and welcome back to Invent Anything. In this episode, we're going to learn how your IP can be enhanced in the prototyping process, or vice versa. After discussing what prototypes are and how the world is changing to make prototypes faster, cheaper, better, and more convincing because our world is flat, we'll talk about how AI and more data relates to prototypes and accelerates and even lowers the cost more and faster. And then we're going to learn about the future of how we face the world of virtualized prototypes. This is John Cronin, and welcome back.
Inventions keep the world spinning. From fire and the wheel to today's high tech, inventions power change. Turn your inventions into reality. Learn how to get your ideas to market. This is Invent Anything with John Cronin.
So today we're going to cover 6 topics. The first topic is the case for intellectual property being enhanced with prototypes. And by intellectual property, I mean patents. And then in topic number 2, we're going to talk about what is a prototype for IP. It's actually different than prototypes for products. Then we're going to get into an interesting subject, which I learned a number of years ago as I started to develop prototypes for clients, that the world is actually flat and prototypes are near free. So we're going to talk about that. You might not know that. Then once we understand that, we'll talk to topic number 4, which is managing this flat world. Once we figure out how to manage it, we'll jump on to topic number 5, which is that prototypes and data now cross into AI, which makes everything faster, better, cheaper again. And then finally, because we're talking about AI, we'll talk about the future of prototypes and also virtualized prototypes. And I chose these 6 topics to kind of go from the basics to the future with some interesting case studies. I think as I think about the audience for this, with my normal podcast on intellectual property and strategy and so on, it's a slightly different audience, but a good overlap. So for those who are considering patent filings, you might think about a prototype. You might have not thought about that before. For those who are interested in the many ins and outs of prototyping, you might consider this a podcast because it will give you great insight about how IP overlaps into prototypes. For those that want to hire somebody that may be doing a prototype, this is a must. We have a lot of experiences in doing this. You might be surprised by some of those experiences. For patent counsels who are writing patents up, I think this is a great podcast to listen to because it might give you some new stuff to advise your clients to do that might help the patent process go better. And for those who want to understand the connection between intellectual property and prototypes, whether you're in prototypes considering IP or whether you're doing IP considering prototypes, this is actually why we put the podcast together. And finally, for those who want to get an understanding of AI in the future, now we need to think about prototypes. And boy, this line gets very blurry. So coming up, we're going to learn how prototypes enhance IP by making ideas tangible for stakeholders to understand and learn the value. We're going to talk about how prototypes help us improve communication, demonstrate feasibility, attract investment, accelerate development. We'll even learn how prototypes can help with collaboration, engage customers, enhance licensing potential, and compelling other ways to get value out of intellectual property. And finally, we'll learn about IP-backed prototypes, highlight innovative features, showcase scalability, strengthen the patent application, and effectively help engage investors and all stakeholders. So listen up with what's coming soon. So let's get into topic number 1, the case for IP being enhanced with prototypes. I mean, it's probably a novel topic, right? I mean, who would be thinking about that topic, particularly if you're developing IP? But because of the world that I live in, developing IP for clients all over the world for many decades, prototyping comes up all the time. And we decided to start developing prototypes for clients to help them off and on. And I have to say that being an intellectual property expert, the more I got into prototyping, the more fun I had, but the more I started to see the synergy between the two. So let's review it. One of the things is that you can really enhance understanding. That is, prototypes make your ideas tangible. They make it work. Most technical people, investors, etc., don't read patents or understand claims, but they certainly can understand when they look at a prototype. So that's certainly one good reason. Another case for how IP can be enhanced with prototypes is that they improve communications. You see, prototypes serve as a common language between investors, inventors, potential partners. They say that one picture's worth 1,000 words. Heck, one prototype's worth volumes and volumes of data to try to convince somebody. And another way of thinking about the case for IP being enhanced with prototypes is it's proof of concept, right? There's no way that someone's going to say, will this work? Because they're actually seeing it. Another thing with the case for IP being enhanced with prototypes is its market validation. Early stage prototypes can be tested by target users. You can hand it to them. They can see it. They can test it. And that ought to help them really understand the benefit. It turns out that the case for IP being enhanced with prototypes also is wonderful for attracting investors. If you're thinking about doing licensing or monetization of your IP, think about doing prototypes. And we're going to talk in a future topic area here about how you might be very surprised how quickly it can be done and how little cost it can be done. Everyone enjoys a working demo. Why not get one for your patent? Another thing about the case for IP enhancing prototypes is speed to market. You see, prototypes help identify and resolve design, features, functionality issues, etc., and can accelerate things. That's the reason why you do a prototype. But when you're developing the patent and the prototype together or one after the other, it can actually accelerate not only the final product out of the prototype, but it might change the way you start writing up the patent. Customers and licensees will get much more sold on a prototype than they would on just the patent. So if they can be sold on the patent, the prototype will help them very strongly be sold on the patent as well. Another case for IP enhancing prototypes is that it's a competitive advantage. You see, having a prototype can differentiate your IP from competitors who may be trying to leverage their IP but not have the prototype. A lot of times, someone might be considering buying IP or licensing IP, looking at different IP from different entities. If you have one with the prototype, you're going to go right to the top of the pack. The secret is here that no one knows how little time your prototype had taken to be developed. And I call that a little known secret because I could tell you that most of the people don't understand how quickly prototypes can be developed. And we'll talk a little bit more about that. Another thing, the case for IP being enhanced with prototypes is it leads to all sorts of collaboration opportunities. You see, prototypes can attract collaborators. As soon as they see the prototype, they can start getting on board and thinking about additional things that they could do with the prototype. It also allows you to reach out and get additional expertise, maybe having some suppliers or some experts that you didn't know about that can be brought in to the prototype and hence can be brought in to your monetization process for your patent. Heck, you can use others to help sell your patent because they were part of the prototyping process. Another great use for the case for IP being enhanced with prototypes is that it helps with customer engagement. See, when you're engaging potential customers with prototypes, you can build their interest and anticipation about the future. The customer can see how they can use the results of your IP much more quickly and easily. And they actually sort of get excited about this because they can now really engage in the prototype and see how their future might be enhanced more quickly with the prototype. Another thing clearly is licensing potential. If you're licensing or monetizing IP, a prototype will help dispel any operability issues and get people physically engaged in what can work and what can't. And finally, the case for IP being enhanced with prototypes is risk mitigation. Nothing speaks better than having a prototype to see if it works. And also a prototype will show you where the real risks are going to be. So as you develop your prototype, where is the hottest issue? Is it in some software algorithm? Is it some piece of hardware that needs tuning or whatever? Is it some material that needs to be cheapened or replaced with something that's more functional? There's a lot of reasons why, as you develop your IP, you understand the risk, but when you develop the prototypes, you can actually see the risks and then use the prototyping process to mitigate those risks. Well, now that we understand that, let's jump over to topic number 2. What is a prototype for IP? Now, that may sound like that's a 2-minute discussion. But actually, what I found is, boy, there's a vast difference between prototypes for products, prototypes for product demos, prototypes to convince the customer, prototypes to convince investors, but prototypes related to IP. What is that about? It's a very specific class of prototypes. So let's get into it. One of the things is to try to differentiate prototypes for IP versus prototypes for products? You see, well, product prototypes focus on demonstrating the use and functionality of a product and its features. IP prototypes emphasize showcasing the innovative aspects, the technology concepts, and more importantly, how the prototype shows how the claim works. Products don't do that. Prototypes don't do that. Another issue about prototypes for IP is demonstrating the key IP claims. See, claims provide all the system elements put together in a certain way. So will your prototype. A product prototype may not do that at all. It may stress some of the functional benefits, and it might not have one of the system elements in it. It might just show the functional result. So this is a very big difference between a product prototype and an IP prototype. One of the great things about the prototype for IP is that the prototype for IP basically shows the platform concepts versus the product features. So you see, you can make a product demo work in multiple scenarios, but you can use an IP prototype and change certain functionalities to actually show how the technology can be morphed in certain things. So for instance, if you have an algorithm that's running at a certain speed, the claim of a patent might talk about that it can be run at multiple speeds. In a product demo, you have it locked into one speed. So you might be able to adjust the speed of the prototype to show how the algorithm might work faster or better or cheaper. Another thing that the prototype does for IP is that basically when you start talking about cost, prototyping for products can generally demonstrate how innovation leads to things like reduced costs. Prototypes for IP don't do that at all. They're more about the possibilities, about the various applications that can be added, about the things that you can use to expand the invention and the prototype. So product prototypes take it in a very different direction. One of the things about the prototype for products versus IP is for IP, one of the things that makes sense is to think about scalability and flexibility. An IP prototype may showcase scalability and technology flexibility and how it can be adapted for various situations. Once again, how you can tweak the prototype to behave in certain ways, which you wouldn't do with a product demo. So it's a wonderful way to showcase scalability and flexibility of your IP. Another thing about the prototype for IP is showing future directions and potential, whereas IP prototypes can highlight really the future developments. You see, a prototype of a potential can be designed into a prototype that goes beyond the limits of a product demo to really kind of change and modify that prototype to show really how fast or how better or how more precise something would work. Product demos don't do that. One of the key things about prototyping for IP is it shows the proof of concept of the IP. Nothing speaks better than showing the actual prototyping working based upon the claims of the patent. Another thing the prototype for IP would show us is integration capability, meaning that the prototype for IP could show how the technology integrates to existing systems. So now I can bring a system or a platform in, put my prototype into that system, and play around my prototype into the existing system to show the interactivity. Generally, product demos are not featuring the interconnectivity generally. It's boxed up and it has boundaries about what it's really doing. So the way to think about a prototype for IP versus a prototype for products is you're actually building in a prototype the ability to get into pieces, areas of the prototype's platform and to be able to change it, to show someone. The product, you'd never open up that back plane or that box to change those things. Another thing about prototypes and IP is that it's for patent application support. You see, with the prototype, you can vary the prototype to collect all sorts of different data, and that data can help support the claims. And a product demo wouldn't do that. You're not trying to collect various amounts of data on various variabilities of system elements or functional things. And also, one of the things about prototypes for IP is technical challenges and solutions. You see, product demos tend to answer customer problems. Prototype IP tends to answer technical problems and the breadth of those technical problems that can change from one prototype tweak to the next. And then finally, when we look at investors and stakeholders, an IP prototype certainly is a convincing thing. We have a client right now that we're developing a prototype for, and they have a group of investors. And if the prototype works, which they would love it to do, and the inventors think that it will, but once we show that the IP relates to the prototype and the prototype works, we're told there's hundreds of millions of dollars available to start developing products and market applications for this. A product development IP is really not for that. It's really for, will that specific market that I got that I'm already growing, will it work? I think a great story is the Oculus Rift. When Zuckerberg saw the prototype that these two guys had, he invested several $1 billion because the prototype was actually showing functionality. Oculus Rift at the time was not a product. It was a demonstration of technology platform. So since we've covered that, let's talk about what's coming up. What's coming up is talking about the world is flat and how we're going to manage this flat world. We're going to learn about the globalization impacts of prototyping, how the world's interconnected in ways you might not think, how things like cloud computing, 3D printing, no-code platforms are revolutionizing the way prototypes are being built. We can discover how AI and machine learning can help optimize design, how they can automate tasks, how you can invite AI as a team member into the room, if you will, how crowdsourcing and AR and VR work. We can understand the importance of managing prototypes by effectively finding key players, securing IP issues, and resolving all sorts of other issues related to the intellectual property. So stay tuned. So let's go into topic number 3, the world is flat and prototypes are near free. A number of years ago, Thomas Friedman wrote a book called The World is Flat, and in it, he describes the profound changes that globalization was doing, how all of a sudden that you could be using the internet to design things and then working with China to develop a prototype or a product, or bringing in top scientists from Russia to do the math on some algorithm and then using that algorithm in your software that then gets downloaded into some other system that then produces yet another device, etc. And the interconnectivity was one thing, but the cost of doing this was going way down. Everyone today, I think, recognizes, doing business, say, with India, where their hourly wage is far less, or doing things offshore in Mexico. But now what's happening is the world is all connected with emails and software and mechanical Turks to get the job done. So I want to riff off of that. I want to basically talk about how that has to do with prototypes. First of all, if the world is flat, one of the things that helps to make things go very quickly is cloud computing, right? The advent of the cloud is such that now it's revolutionized prototype development. You can go up to the cloud and get any kind of third-party algorithm that you want almost for free. It can do any kind of calculation. We're working on a project today that, if to try to do a prototype, 5 years ago would have been impossible. But today, almost all the algorithms are all open source, they're all in the cloud, and we can get them for free. Another thing is, who would argue with 3D printing, right? The world is flat and prototypes are near free. Well, 3D printing is no longer something of the big boys. You could buy a 3D printer for $300 or $200. You could buy a big 3D printer or a small one. You can 3D print any kind of metal alloy. I mean, come on, 3D printing is on the desktop. And so now you can literally take a design and print it in a matter of minutes or hours. There are companies that have sprung up everywhere that do anywhere from 3D printing for doctors who are doing knee replacement through 3D printing for, whatever it is that you need, even 3D printing for food. That's the world we're living in. The world is flat. Well, let's add something else to it. Let's add the concept of no-code, low-code. So no-code, low-code is a new software development platform that allows you basically to create software programs from basically little bubble charts or organizational charts where you put in functionality at a very high level, and all the code underneath it is already written. You can develop templates and menus and all sorts of things and connect all the fields to all the software and really not write any underlying code. So no-code, low-code is being used by lots of clients that we have and lots of businesses to get code faster, better, cheaper, more robust, and easier for the programmers to program. Here's another one. The global talent in the gig economy. We've heard the word gig, right? The gig economy. I mean, today, even in America, a huge percentage of Americans don't go to their office. After COVID, we learned that we didn't have to go to our office. But even before that, people were sort of doing job shopping, doing gigs. And that's what's happening, that sometimes companies comprise nothing more than hundreds of giggers. And so think about the possibility of, as you're developing prototypes, that there's really, you can reach anybody. to be an expert in any component part of your prototype, practically for nothing. Another thing is AI and machine learning. Look, with ChatGPT and large language models and Claude and all this kind of stuff, we've now gotten to the point that AI is on your desktop and becomes a low-cost super intern. I call it the Oracle of Delphi. You can ask it any question and it will give you the answer. Now, you have to be smart enough to know if the answer is, in the right ballpark or not, but certainly help prototyping and AI machine learning, unbelievable. You can ask it design stuff, draw stuff, analyze stuff, put in sample data. It's unbelievable. Another thing about the world is flat, beyond what Friedman was writing about a number of years ago, is crowdsourcing. That really exists today. There are all sorts of platforms like Chopcoder or Upworks, etc., where you can literally find an expert. I was searching for an RF designer just this morning with one of my staff on Upworks. Within 15 minutes, we have 4 or 5 people basically bid at a per hour basis from 30 to 40 hours to $100 an hour. Top engineers, RF designers who will literally work for us at a distance for a small piece of work, maybe $500 worth of work. One of the things about the world is flat is where prototypes are near free is augmented reality. I bought myself a Vision Pro just recently. I put it on as a great program where you can bring in an object from a library, and this was a jet engine. I pinched my fingers, and there it was in front of me. It was 3-dimensional. I used my other 2 fingers to expand it. So now this jet engine got big. I could rotate it. I could move around it. I hit the button, the cowl on the top of the jet engine. I saw it, it flashed, so I grabbed it, I picked it up. So now I'm looking inside the jet engine as it's running in front of me with the Vision Pro. And then I could take out a little pipe, which might have been a fuel pipe, and look at it and stick it in the air and leave it there, start taking pieces out. We can hit a button, it puts it all together, it shows it running. You can take a piece out, it won't run. That's today. That's today. That's amazing. Another thing with the world is flat, where prototypes are near free, is not only are these tools available, but now there are prototyping tools available. CAD systems that literally allow you to design things by you interacting with it with a text-based interface. You could say, design a glove that has 5 fingers, where each finger has a ring on each finger. And each ring is going to be lit up. It's going to be a different color based upon the stress of the finger in the glove. And I want it to connect to a controller such that when I hear music, I want the rings to light up. And I want it to essentially move around in space, where as I move my fingers, the stress on it will actually change the color of the rings. So the music changes the color of rings, and my hand changes the color of the rings. And I want to use this as an entertainment device. You type that into the tool, and out comes a prototype, 4 or 5 of them, pictures of them. The world is certainly flat, and prototypes are certainly near free. Another thing is rapid prototyping. We talk about 3D printing, but it's everything from CNC machines to laser cutting to plastic forming. You can literally, for a couple $1,000s, buy pretty much anything to do development that large companies would have in their R&D 10 years ago. You can buy for the home. And we can also integrate IoT devices. For instance, you can have a tiny device that can measure stress or strain or temperature or pressure or whatever, stick it anywhere in your prototype, have it wirelessly deliver data. So now you can collect reams of data on your prototype if it's a physical one. And I could go on and on and on about all the things that are making prototypes free, cheap, fast, and easy. So just think about that. The world is flat and prototypes are near free. And in the future, they'll be almost instantly made at almost 0 cost. So let's go to topic number 4, managing this flat world. Well, what does that mean? Well, as I started developing more and more prototypes with my team and started using all these things we just talked about at topic number 3, prototypes are near free, the world is flat, I started recognizing that one of the things that's not as obvious is how you manage this world. So let's go through that. One of the things is, if you certainly knew about all these various teams and services like Upworks and Topcoder and Pfizer and all the rest, that would be better, because if you didn't know they exist, then you wouldn't be able to take advantage of them. So managing the world is flat means knowing these resources are available. Another thing I found that it's very important is vetting the experts. You see, developing a prototype does take maybe some expertise of others, but how do you choose the right person for the right job? You have to know something about what you're doing. So sometimes you have to hire an expert to help you find other experts, or have a prototyper find other prototypers to do certain bits of the job. Another thing is, that's what's really important if you really want to prototype fast, better, and cheaper, is how do you integrate all that expertise? So knowing what to do first in the prototype, what to do second, what things can you do in parallel, what things can you do with mock data? So managing that flat world by integration of teams and experts is important. One of the key things of prototypes I've always found is that getting right to the jugular of what's the hardest part of this prototype to pull off. And on a different level, what's the part of the prototype that if I just analyzed it in a portion of it, it would be better. It would show that the broader thing had worked. So we're working on a project right now where we're collecting data in a particular process. And by varying the process, we have different data. And so we're asking ourselves, can we write an AI algorithm for the different data? Well, what we found is each of the datas for different group experiments have different waveform shapes. So we were smart enough to say, you know what, before we write the AI, let's look at those shapes. We have, say, 3 or 4 different waveform shapes from 3 or 4 different process operations. We can actually double-blind experiments and give 10 users the pictures and see if they can put the pictures back to the right box, the right experiment. And if they can put the right picture in the right box by looking at it, then the AI would certainly become easier to run. We would know that AI was more possible. So this is what I mean is trying to find out those critical elements and to go after them and prove those work before you try to prove all the rest of the things in the prototype. Another thing in the managing the world is flat is shopping for that expertise is one thing, but then getting it in place and then managing it to implement, to keep people on budget. You can hire an expert that's the right one, but they have their own life. And so you need to cooperate with that expert and those experts and have them work as if they're part of a team that you're managing in your office. So that takes focus, takes discipline. One of the things that happens in managing these world of flat experts is non-disclosure agreements. I give the example of the old tale about people trying to, describe what an elephant is. So there's 10 people, and they all have blindfolders on. One is grabbing the trunk, the other the ear, the other the foot, the other the tail. Now, as they would tell you their observations, you don't know the elephant. And unless you have enough people touching enough parts of the elephant, you wouldn't be able to really know what it was. You have to treat your prototype like that. It makes no sense to bring in experts and tell them everything you're doing. You tell them just pieces. And by doing that, you keep your prototype confidential. But certainly nothing is better than getting a good non-disclosure agreement. Getting a non-disclosure agreement with experts is great. But what if that person happens to be in a foreign country? And what if that person violates the NDA? How do you enforce it? So there's a lot of things to think about when you want to manage that flat world with non-disclosure agreements. Another thing to do when you're managing that flat world is understanding IP rights. One of the things we recognized long ago by some mistakes we've actually made is that it's much better to find an expert and ask them to tell you about the problems of something versus asking them for ideas. So if there's an opportunity in a particular part of the prototype where you want some information, have them teach you a mini course and have them answer questions about what they see as problems in certain things. And then you come up with the ideas later. The reverse is asking the expert to come up with ideas to fix your problem. As soon as they do, they could be the inventor. And then once again, how do you capture those IP rights? Of course, you want to have IP rights in the agreements, but what happens if this person's in another country where IP rights are not respected? You get the IP rights from them, but maybe you've lost them already. Another part of managing the world of flat is dealing with the problems over solutions, meaning it's far better to ask experts to help you define some of the problems that maybe you can fix versus asking them for solutions, as I just talked about. But maybe have one expert work on the problems. And once you figure out the solutions, have another expert work on the solutions. So therefore, you're maintaining your NDA, optimizing your IP rights, and once again, optimizing it by obfuscation because no one knows what the elephant really looks like. Another thing is, and this is essential, and this is hard to describe, but managing this flat world, you've got to be very inventive about the approaches you use for prototyping. Sometimes you have to invent the thing to get your prototype to work. I once had a student where they were trying to invent stuff, and we basically went through the process of saying, let's come up with an idea, and we came up with an idea of how to make paper so it wouldn't give you a paper cut. Simple concept, right? I mean, we've all gotten paper cuts. And so with the student, we ended up asking the question, what causes paper cuts? And so we got a piece of paper and we put our finger at the end and kept swiping it. And all of a sudden we recognized that when you get a paper cut, because I actually got a paper cut to see, is that the paper was stiff enough and I went fast enough with the right pressure that I created a slice in my skin. Well, we started brainstorming and asked the question, well, how do we stop that? And we came up with things like thicker paper or roughened paper. And then finally, we came up with this idea of how about a piece of paper, 8.5 by 11, where every 1.5 inches, we cut just a micro divot out, which you might not be able to see. And we tested it. We cut little divots out of the edge of the paper. And as we raced our hand across it, we recognized that this would work. Surprising to me, the next day, the student came in with a bunch of papers and they had these micro cuts on it, but they were kind of uniform. And it turned out that the student took the Reynolds wrap, which has that little serrated knife edge that cuts the Reynolds wrap. And basically they use that to create the perforations on the paper. See, that's being inventive about the key problem. So they're able to very quickly produce prototypes because they're inventive about how to get the prototype to be developed. Another thing in managing this flat world is using modern prototyping equipment. We mentioned 3D printing and CNC and laser cutting and all that stuff. We also mentioned CAD programs and all the rest. We also mentioned these online tools that you can just talk into it, basically. You type a paragraph of what you want. But by the time I finish this podcast, there's very likely 10 more tools that'll be better than what I'm talking about. So it makes sense to continue the journey and look at more tools. One of the things about prototyping is that, and people forget this, or somebody doesn't recognize it as being important. As you're doing prototypes, every 2 or 3 days, you're learning something. This is getting built, and that's getting built, and this is getting integrated, and that's getting integrated, and then you've done this, and then you've done that. Well, with a little bit of effort, you can, every single day or two, write a mini report. These mini reports, basically, at the end of the day, will suffice as all the data that's needed, because when you deliver the prototype, you can deliver how we operate the prototype and how it was built. That data is worth just as much as the prototype. So this effective communication and documentation is really important. Well, coming up, let's explore how prototypes and AI come together to transform the process. Let's look at things like rapid data analysis, predictive maintenance, all sorts of issues of crowdsourcing, AI's role in optimization for design. Let's learn about the future of AI, about things like AR and VR, and how we can do things like collaboration platforms and predictions, and also the future-proofing of designs. So stay tuned. So now let's go to topic number 5, prototypes, data, and AI. One of the things about prototypes, data, and AI is that we can now do real-time data collection on almost anything we do. If you have a physical prototype, that's different than a software prototype, but a lot of prototypes that are physical, you can start putting sensors all over the place and collecting real-time data. See, these IoT devices are almost zero cost. It can measure pretty much anything. So putting them a number of places on the prototype would be great. So you could pretty much measure anything, and the data is flowing into a database. And now you can have large language models produce algorithms to create all sorts of a data analysis. So getting the data is almost for free, and doing the analysis is almost for free. And now you're doing what large companies 10 years ago would only dream of in developing a prototype. The fact that we can now do AI data-driven analytics is also something. You can literally take a table of data, put it into an AI tool, and ask questions about the data. Ask it to find sensitivity, ask it to find the peaks or the valleys, ask it to take the data and filter it and analyze it, ask it to provide insights. All these things are possible with AI data analysis, which is really wonderful because that used to take researchers hours and days and weeks. One of the things you could do with the data and AI for prototyping is to look at it and ask questions, as you see the data changing, do you think this particular thing, this sensor, is showing that what it's measuring will show fatigue? Or is there places that we can preemptively look at data and say this piece of data is more erratic than this other piece of data? So maybe this sensor is measuring something that's more erratic. So maybe there's more focus on whatever it is that sensor is attached to. So not only can it analyze stuff, it can predict stuff. One of the great things about data AI and prototyping is that now we can take data and put it into the cloud and go find someone from the crowd to look at the data for us. So remember that RF design engineer that I was talking about that I'm going to hire through Upworks? Well, I could be collecting data on my prototype and send the data to the RF designer and ask that RF designer to analyze it for me. So now what's going on is my crowdsourced designer is looking at data rather than having to build the whole thing, because I can now take data and put it across the internet. One of the great things about AI in the future of this is that simulation and modeling can now be used for everything. We have simulation and model tools. And by the way, a lot of them are open source to be able to use. I was searching on YouTube for a number of hours on a project to find out there was an Indian group that had developed a CAD system that would analyze a certain material where you could put in different materials to build different parameters to build a material, and the material would change and give you data back, all virtualized. So if you search, you may find through crowds or through YouTube that there's somebody already working on some part of this where you can simulate and model. And also we can use prototypes and data for automatic testing. Right now in one prototype, we have the AI producing mock data. Let's just say we have a block diagram with 8 blocks in it. Each block we have to prototype. When one block does its work, it passes it to the next block. And that block does its work, it passes it to the next block. So what we're doing is we're using AI to create mock-up data, pretending it's the first block, giving it to the second block. We have AI pretending it's the second block, running the data on the first block. And we do that for each block, and then we concatenate them. So by creating mock input data to create output data based upon the AI actually creating the results of experiments, we actually have the whole thing laid out. We're developing the prototype without physically writing any code. That's pretty powerful. One of the things we're doing with prototypes, and certainly for those people that are trying to integrate prototypes with data and AI, is to use AI for design optimization. Take those set of blocks. The next question would be, how do I optimize the algorithm in that block to get the better output from that input? So now we can use AI for design optimization. One of the nice things about AI as well is that when you're developing prototypes, you can literally sit in front of an AI engine, a large language model, for instance, put in the design elements that you have, and ask questions like, how could I minimize the cost of my design? Believe it or not, you might get answers back like you'd replace this circuit with a chip that's well known, and the chip costs $1 versus the 10 components you're putting together that cost you 20. So you can literally use AI for cost optimization. You can use AI tools for prototyping. You can literally create AI-enabled tools to visualize, create, analyze your prototype. So stringing some tools together, the output of a visualization of a prototype would then go into a CAD tool to exercise that prototype's virtualized image in the CAD tool to then look at critical parameters. And then, of course, this whole user experience. When you're showing the result of a prototype, you're showing it to somebody. AI can actually produce a whole visual output of a design that's virtualized. So you can say that I'm developing this cup that is being heated by a heater element at the base of the cup by battery. And the material is special, it has some iron and some ceramic in it. And I'm designing this cup, and the cup basically, when you pour hot water into it, basically keeps itself warm. And basically without this cup, this hot water is going to get colder. So I'd like to visualize 2 cups next to each other. I'd like to show water being poured into both. I'd like to show the average temperature in each cup by how red it is. And I'd like to show it over time. And I'd like to turn my cup on to heat up the cup. And then what happens is the video gets created where you actually see my prototype cup keeping the fluid warmer longer than the one that doesn't have it. All I did was describe it, and then I get the video out. So we can see how the whole thing can become virtualized, the whole thing, from your computer without building a prototype. And then if you're convinced, well, maybe you build a prototype. Well, look, the next thing to talk about is the future of this. Topic number 6, the future of prototypes and virtualized prototypes. We talked about AI-driven pattern analytics and how we can use that. We didn't talk a lot about mechanical Turks and how you can define the ability of going from one workflow to the next, and each workflow is in an overall program called a mechanical Turk. And you can literally have something in one part of a design be done and another part of the design be done by separate people doing separate things. And then the software ties those together so that they can literally create the integration. We actually see that for the future prototypes and virtualized prototypes, that automated software development is happening as well. You might not know this, but you could ask ChatGPT to ask it to create Python code to run something. Right now, this morning, we had a meeting with some of our staff, and we're using a large language model to create software code for us to develop a user interface. I'll probably have it before this podcast is over, and that was 2 hours ago. That's powerful. One of the things we're doing is we're bringing AI as one of our team members. So we have 3 or 4 team members building a prototype, except one team member is called the Oracle at Delphi. It's someone running a laptop that's connected to different large language models, and we're asking it questions, and it's giving us answers, just as if it was a member of our staff. How about that for a low-cost prototyper? We're visualizing prototypes. As we're talking to the computer, there's other programs that take that text and turn it into visual images. So now we have the Oracle at Delphi giving us information and another program showing it how it works. We're able to have more collaboration in the platform. We're able to take these various tools, these various integrations, and put them together as if they're a whole laboratory or a shop. Once we get this going, we now know that the prototype is a set of blocks with a set of information. So now we can have data associated with those blocks and do predictive analytics. Once we have that done, then we can do automatic testing. Once we have that done, we can use large language models to ask questions of that data. Really powerful stuff. And finally, as we do this stuff, we can use AI to help generate instructions, how to use it. It can create the reports. We can use AR and VR to help us integrate it by putting on, say, a Vision Pro headsets and putting it in a 3-dimensional world and taking physical models and actually looking at it in 3 dimensions in a augmented reality. I mentioned that jet engine, for instance. We can use the AI then, once it's all done, to ask you questions on how to reduce costs and how to improve performance, and to put that in the report. So when we deliver the prototype, we can deliver all of these reports that we've kept track of. We can deliver the prototype. We can deliver all this analysis, all this testing, and then we can deliver a whole report on how you can start scaling it or reducing the cost. So now, around this one concept of prototype, it's as if you put 50 people to work in before, during, and after. And then, of course, don't forget intellectual property, which is where we started the journey. You can use AI to help you develop the intellectual property protection, where the inventions are in this prototype, have it suggest to you. And you can also then use AI to help you develop the IP. And then finally develop this documentation that we mentioned, the documentation of the design, the documentation of the testing, and have that all developed automatically. And then finally to develop the whole future proofing of the design, to say now that we have all this data and this is how we're going to improve it in the future, we can now actually say this is what the data will look like if we improve it in the future. So what we talked about is much more than a prototype, right? We talked about the prototype as if we delivered a complete system with all the analysis of the past, the present, and the future. That's more than a prototype. But what I'm saying is that is our prototype today. Instead of having a prototype, which is a desktop thing that just does a function, today, because of AI, we can deliver all of this as a prototype. It's truly amazing. So why don't we wrap up? In topic number 1, we talked about the case for IP being enhanced with prototypes. We discussed all sorts of things, how IP can help with a prototype improve communications, have common language with investors and partners. We talked about early stage prototypes allow for market validation. We talked about how you work with prototypes to attract investors. We talked about prototypes fostering collaboration. We talked about prototypes helping enhance licensing potential and even how to mitigate risks. In topic number 2, we discussed what is a prototype for IP. Talking about the differences between IP for a product versus IP for prototype for a product versus a prototype for IP. A prototype for IP really differs than a product prototype because it focuses on showcasing things like the innovative aspects, the technology platform. It's a clear visualization representation of the IP's novelty. We talked about how the IP prototype demonstrates what's in the claims of the concepts, not the product functionality. We talked about the IP prototype showcasing the scalability and flexibility of the technology, not the specific limitation of the product features. We talked about the IP prototype demonstrating how technology can integrate to systems. We talked about how the IP prototype can actually show you how to modify and change parts of the prototype and show that regarding the claim variation, etc. And then we finally talked about addressing the technical challenges that the IP prototype is showing technical problems being solved, where the product prototype is really talking about the customer problems being solved. So whether it's a shade of gray or major differences, there certainly are prototypes, differences for IP versus prototypes for products. In topic number 3, we talked about the world is flat. We talked about Thomas Friedman's book. We talked about all the things that happen in globalization, the rapid connection of the world together with technology and clouds. But as we started talking about the world is flat, we recognized relative to prototypes, the top is off of Pandora's box. We talked about the rise of 3D printing, the cost affordability of it. We talked about no code, low code. We talked about things like crowdsources like Upworks and Fiverr. We talked about things like advancements in AI and machine learning. We talked about AR and VR and that technology that allows you to see prototypes working in virtual space. We talked about all the other types of equipment, the CNC, the lasers, the plastic forming. All those are now tools that you can buy. You can have in home for a couple $1,000s instead of needing a complete fab that could cost millions. And then we talked about how we can create smart prototypes that allow it to interact with other parts of the system where you can do testing and validation. And all that is in the world is flat, meaning that we can connect to all sorts of experts all over the world to give us all that information. Once we talked about the world is flat, we talked about topic number 4, which is managing this world. This is a very, very unique topic because you might decide to do a prototype. Good. You might decide to start using experts. Good. You might decide to start using 3D printing and crowd and all that rest. Good. And you might decide to start doing some of these things we're talking about. Excellent. But what you're going to run into as a brick wall is the ability to start this process off, figure out, how to manage all these experts, how to verify the experts. You're going to have to start worrying about how to ensure that you don't lose your rights. What is an elephant with the 10 people touching it? You're going to have to start worrying about intellectual property. You're going to have to start worrying about how you can pull this all together in an integrated way, get the feedback, and then use it to develop the prototype. You see, managing all this stuff is a very difficult thing. So knowing it exists is the beginning, but as you get into it, I think it would be great to have some expertise along the way to show you how you can integrate it, manage it, and make sure it stays on course. That then moves to topic number 5, which is, okay, now that we know the world's flat and we're managing it, we know IP prototypes versus product prototypes, we know all that. The next question is, well, how do we develop our prototypes? And even better than that, how do we start using the data from it or AI from it and AI and the data from it to really improve things? We talked about AI-driven data analytics because of all the IoT devices you could put around your prototypes. We talked about how you could use crowdsourced feedback in online platforms. We talked about online simulation tools, digital twins, for instance. We talked about the variations that one would get on performance data and testing data, and even how you can look at AI to help you determine costs and predictive maintenance and things like that. And we also talked about these tools that can help us visualize, create, analyze, and actually document. So prototypes and data with AI really goes to enhance, to get the prototype out fast, quick, and cheap. And then finally, topic number 6, talked about the future of this. We literally talked about virtualized prototypes at the end of the day. we talked about basically how these AI systems can be used with mechanical Turks, where one piece of software can integrate 10 experts all working on separate jobs. Once that mechanical Turk is set up, then what's happening is the process of getting others working on various stages of your prototype is going. And they're using AI in their own systems as well to visualize, to analyze. And collaboration is now occurring in a unique way. We're talking about then how you can do predictive designs and doing data analytics. And then we're talking about how we could take that data and start visualizing in AR, VR, on your Vision Pro, for instance. And then we're talking about, as that's being developed virtually, you can now take a look at it and have it run the experiments and actually then show the marketing data. And then also automating all the output data and the reports, and then automating the how to use package and the specification package. At the end of the day, we can use it to even future-proof the design. So now our prototype is designed virtually, by the way, before we even start the physical reality of developing it. That's our future. Is that the prototypes basically will happen almost instantly. I have a bit of a dream here. The dream is that someday this prototyping with AI, I believe that an AI will be able to read your patent and instantly be able to create a prototype of it just by reading your patent. To see it, to test it, to have a model for it. In the future, maybe it can use that to actually kick off a set of physical mechanical Turks to actually create it, to start the 3D printer, to build that printed circuit board. Humanoid robots are already available, coming online even faster with large language models. It may be possible to take that patent, have an automatic prototype built in virtualized worlds, and then set it to work with the humanoid robot to build it. I have that dream that I think that that's very possible and is around our corner. So thanks very much for chiming in, and if you like what you see, please subscribe, and please come to our blog, Invent Anything, maybe listening part of our new series, Invent as a Work. This is John Cronin, Invent Anything.